46. 231, yes. Just making sure. Okay, so f of x equals x squared minus 4 divided by x plus 3. I would immediately change this if I were to graph the entire function, or you just want to determine the asymptote. What are we trying to do? What would you like it?
Do we graph the entire function?
Yes, so we want to do the whole thing. Very good. Okay, excellent. Good. So remember, I'll get my table going. F prime of x, f of x, and the second derivative. We'll start with the domain. You don't have to write it separate. If you put it in the table, I'm fine, unless calculations are needed, and then the calculations have to be shown. Can anyone give us the domain of this function?
It's negative infinity, -3, union, -3 to infinity.
Excellent. Thank you very much. Okay. Which means, because x plus 3 does not go away, it means that x minus 3, x equals -3, is a vertical asymptote. So then I know I have to find the limits here and also here, of course. Good. Now, when is this function 0? If I set this equal to 0, can anyone tell us when is that, for which x values is that function 0?
X equals 2, x equals -2.
When the numerator is 0. Thank you very much. So -2 and 2. Make sure you put these numbers in the correct order, because if by mistake you reverse anything, it's going to be a big deal. And now let's plug in 0 to determine the y-intercept. What is the y-intercept?
-4/3.
Very good, awesome. Indeed, when we plug in 0, we get -4/3. So I'm almost finished with the function. I need this, 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 and this. And the slant asymptote. And then I'll move on to the first and the second, and finished. After that, when I put everything together, I will be able to graph it. Okay, so our next step, that's page 5. I want to find the slant asymptote. So remember, we divide x squared minus 4, because there is a missing term here, the term with x, and I divide by x plus 3. If you want to use the long division, if you want to use the synthetic division, I think we did the synthetic division last time, so let's work on the long division this time. X times what is x squared? What do I put up here?
X.
Very good. And then I distribute it. X times x is x squared, but I have to change the sign because I subtract. X times 3 is 3x, but I have to subtract. See, I would have not been able to write it under this. So they all have to be in a correct order, descending order. These two go away, then -3x, and then -4. Final question. X times what is -3x? And I have to put it up here.
-3.
That's it. So -3 times x is -3x. Change the sign. -3 times 3 is -9. Change the sign. So in the box, these two go away. In the box I have 5, which is the remainder. Remainder, and this is the quotient. I'm going to write it one more time. And this is the slant asymptote. Just the quotient. So our function initially was x squared minus 4 over x plus 3. It can be rewritten as quotient plus remainder over the divisor. And this is the slant asymptote. Y equals x minus 3.
I had a quick question.
Yes?
If you were to do the other type of dividing, the other type of division that we did
The synthetic division has limited applicability only when you have a divisor that is linear.
Yeah, but when you do it, if it is like that, so I know usually you put, I think the number, okay, so it would be negative if it says x
Yes,
plus
because
3.
this has to be written
Yeah.
as like this.
Okay, that's why I couldn't remember.
Yes.
So when it
So
was,
I copy the leading coefficient. I multiply these two. I write the answer. I add. I multiply these two. I write the answer, and I get to box in the remainder. 1 minus. So
Thank
x,
you.
sure, minus 3 plus 5 over x plus 3. So now when I determine the limit as x approaches infinity, it's easier to determine it from here, not from there. It's the same thing. Doesn't matter. But look what happens. And then later on I will determine the negative infinity. So where does this go when x approaches infinity?
0.
Exactly. Where does this go when x approaches infinity?
Infinity.
That's it. And the same thing here. So the other one will be negative infinity. So that's why it's so much easier. Once I have it presented like this, it's so much easier to find the limits at infinity. So at negative infinity is negative infinity. At positive infinity is positive infinity. Now I need these two. And I prefer that form for these two. And then we can look at the first and the second derivatives. Okay. So where is it? So limit as x approaches negative 3 from the left of x minus 2, x plus 2 over x plus 3. And limit as x approaches negative 3 from the right, x minus 2, x plus 2 over x plus 3. Okay. So when x approaches negative 3 from left or right, it doesn't matter. Where does this go? I need the sign, only the sign. So negative 3 minus 2, negative 3 plus 2. Just the sign of the product. Anyone?
It's positive.
Very good. It will be positive in both situations. And where does this go? With negative 3 from the left and with negative 3 from the right.
Would they both be negative? Or no, the top one would be negative, bottom would be positive.
Good. So then we know the answers.
Negative infinity. And
Awesome.
positive.
Yes, of course. Thank you. So back to negative infinity and positive infinity. Done with this. Now we are here. So we are differentiating. The function is again x squared minus 4 over x plus 3. So we use which rule? Anyone?
Quotient rule.
Quotient rule. The top prime, 2x times the denominator minus the top, careful because of this, times the denominator prime, which is 1. Do not try to simplify anything. So this is 2x squared plus 6x minus x squared plus 4 over x plus 3 squared. And this will be x squared plus 6x and plus 4 divided by x plus 3 squared. Okay, 2x, that was the function. I'm pretty sure. I'm checking. Okay, yes. So we do have 2x I'm just checking one more second. Yep, so this plus, yep, everything is okay. It's not factorable. So I have x equals, when I set this equal to 0, f prime of x equals 0. The numerator has to be 0, so negative b plus or minus b squared minus 4ac divided by 2a. So this is 20. So from here I have x equals negative 6 plus or minus the square root of 20. So this is 2, the square root of 5 divided by 2, or negative 3 plus or minus the square root of 5, but I still have to approximate those. And real quick, negative 3 plus the square root of 5, and negative 3 minus the square root of 5. So I got x negative 0.76 and x equals negative 5.24. Ugly numbers, but I have no choice. Of course, just to mess up my table. And negative point, of course, it has to be here, right? It has to be. Right in here. Okay. So the denominator is always positive. Again, you can plug in numbers for the numerator. In between solutions is always the opposite sign of A. And outside is always the sign of A. You can plug in numbers. Now the moment of truth. Now I'll check whether these two rows work well together. If they don't, something is wrong and I have to go back. Okay. I forgot to find these numbers. If I don't, I can't continue. So y equals, I'm just plugging in the function x squared minus 4 and divide by x plus 3. Don't forget parentheses all the time. And just plug in. I'm going to plug in a negative 5.24 and I'm going to plug in negative 0.76 to get these numbers. That didn't work. Negative 0.76. Okay, so negative 1.53 negative 1.53, and the other one a negative 10.5. Oh, this one I have wrong. Negative 10.5. Okay. So now the moment of truth. From negative infinity to negative 10.5, yes, indeed. From negative 10.5 to this, yes, that's true. From positive infinity to 0, yes, it's true. From 0 to negative 1, yes, it's true. From negative 1.5 to negative 1.3. 1.33. Yes. So 5.3, yes, it's going up. From this to 0, yes, it's going up. From 0 to this, yes, it's going up. So I can say that this is what type of number? Negative 5.24, negative 10.5. What type of point is this?
Relative max.
Yes, it is a max, a local max. And this one, negative 0.76, negative 1.53, a local min by the sequence of signs for the first derivative. Okay, now let's see how messy is the second derivative. Okay, where's my first derivative? This is my first derivative. I have to differentiate it again. Quite messy. Okay, the second derivative. You know you're watching me running out of room. I'm sure that. So x plus 3 to the 4th power, the top prime, 2x plus 6 times the denominator. Maybe I won't run out of room this time. Minus x squared plus 6x plus 4 times the denominator prime, which is 2 times x plus 3. Almost there. Okay. I will factor out an x plus 3, of course. And I also could factor out a 2. I have to be careful not to forget what I'm doing. So I took out a 2 from here, so an x plus 3 is left inside. And I took an x plus 3 out from here, so Another one is left. Nice. I took out 2 in this, and so now I have negative x squared minus 6x and minus 4. Yes, one of them goes away. 2. So this is x squared plus 6x plus 9 minus. Very nice. Wow. I wasn't expecting that at all. These two are gone. These two are gone. Wonderful. So this is 5 times 2, which is 10. Great job. Thank you very much. So it's never 0. No inflection points. However, the sign changes, which doesn't mean anything. It just changes, but there is no inflection point. To the left of x equals negative 3, this will be negative. So the function has to look like this. It has a maximum. Of course, it has to look like that. Here it has a minimum. So to the right-hand side, so I'm just super verifying everything. Of course, it has a minimum, so it has to look like this. No question there. Okay, perfect. So now we're ready to graph. So I only need the table and the slant asymptote. So y was x minus 3. We determined it some 15 pages ago. Yes, x minus 3. Good. So x minus 3, slant asymptote. I have to start with a vertical. I have to continue with x minus 3. And remember, I need 2 ordered pairs. When x is 0, y is negative 3. When y is 0, x is 3. It's a little bit kind of a broken line. Sorry. So y equals x minus 3, x origin y. Good. So now, with a different color, I'm going to graph the function. So let's see what I can do with this point. It's an ugly point, negative 3, 4, 5, 6. So somewhere here, and negative 10. So this was negative 3, 4, 5, 6, 7, 8, 9, 10, 11. So somewhere here. The next point is negative 2, 0. Negative 2, 0. The next point is negative 0.76, negative 1.53. The next point is 0, negative 4/3. And the next point, what am I doing? Nobody knows. Okay, so negative 2, 0, that's correct. Yeah. It's on the other side, it's negative. So negative 0.76, negative 1.53. Right here. And then 0, negative, so this is going up, so it's right here. And that is correct. No, it's not correct. Is it positive 2? I have to move it. Okay. Just a tiny bit to the right. Okay, ready. So, from negative infinity up to a maximum, down to a negative infinity, close to the asymptotes, of course, opening up with a maximum. And I have to extend my vertical asymptote. Good, that's done. On the other side, coming from positive infinity, crossing at negative 2, 0, reaching the local minimum, crossing the y-axis, crossing the x-axis at 2, 0, going towards infinity. Minimum, crossing the y-axis, the x-axis, and approaching the asymptote. So this is the function. Very nice pick. There's a good function. Yes, of course.